Hey, hi everyone. So let's start the session. So I hope we all are aware about the agenda of today. So okay, so this is the agenda that we have for our next 5 weeks. First of all, we will start with the feature engineering and model building, including the EDA. In the next week, we are going to cover machine learning projects, including the deployment, web application with Dockerization. First week, Friday, Saturday, and most probably Sunday, 3 days it will take to complete the feature engineering and model building, because first of all, I am going to start with the machine learning pipeline. We can cover all those machine learning pipeline and then we can start the practical implementation. Again, the next week, you will get the update. Third week, end-to-end NLP project with web application. So here we are going to cover SOTA model. SOTA model like BOT, GBT. I will try to cover BOT and Elmo method here, and some text summarization or something like any other type application we will build in a live class. Okay, from the scratch. Okay. Now fourth week, again a deep learning projects, and fifth week Python projects. Okay, so whatever the concept that we are going to cover here, one by one, let's say the feature engineering. So in the feature engineering, whatever the steps that we have, so we can discuss all those steps, but for the implementation wise, we can implement on our project whatever the requirement that we have in our projects. Okay, so can you please confirm everyone I'm audible or not in the chat? Yes, no? Okay, so this is the agenda, main agenda that we have. So let's start with the first week, feature engineering and model building. So today agenda is, as you can see, I have written each and everything here. So the first agenda that we have, machine learning life cycle discussion. First of all, we can discuss the machine learning life cycle. Then understanding about the problem statement. Because whenever we are doing the any machine learning project on any types of data science project, first of all we can understand the problem statement, because based on the problem statement then we can implement the EDA, data preprocessing and feature engineering steps, and based on those steps we can implement the machine learning algorithm. So first of all we can understand the problem statement, then we can start with the data exploration and EDA. So data exploration, third step that we have. Then exploratory data analysis, where we are going to find out the insights from the data. Let's say we have a one client like Flipkart. Okay, so Flipkart have some of the like shop, offline shop, like one is in a Bangalore region and second shop in a Delhi region. So Flipkart's not owner, like a manager, they want to know, okay, why we are getting a maximum revenue in a Bangalore region and why we are getting the less revenue in a Delhi region. So what we can do, whatever the data that we have, so from the data we can find out the insights. Okay, these are the product that we have in a Bangalore region, that's why we are getting the more revenue. We can say to our client, okay, those are the product that you have, so based on this project that you are getting the more revenue in your Bangalore region, but these projects are not available in a like a Delhi region, so that's why you are not getting the more revenue. So we can find out some of the insights from our data, and based on our insights then we can implement the feature engineering. Under the feature engineering, again we have a different method, as you can see here, like a handle a missing value, handle a outliers. So different things that we can discuss one by one. So let's start with the machine learning pipeline first. So let me, I hope this screen is visible to you all. Okay, let me zoom it little bit. Yes, so this is the machine learning pipeline images that I have taken from the Google. I hope it's visible to you all. Please confirm in the chat. Yes, you are audible. Okay, that's great. Thank you. Now, this is the machine learning pipeline that we have. As you can see here, first we are getting the data set from our client in a form of CSV, in the form of Excel, in the form of database. Okay, so after getting a data set from our client, what we can do, we can find out some of the insight, like We can check it out the head part, tail part, okay, how many like total rows that we have, how many columns that we have, okay. And after that we can do the processing, data preprocessing. As you can see here, data preprocessing and data modeling. After that, next step that we have feature extraction and feature engineering. Again, in these steps I have written here, as you can see, these things: understanding about the problem statement, then import the data, data cleaning, EDA, data preprocessing and feature engineering, model building and predicting and deployment. So the fourth step that we have here, feature extraction. Whatever the data that we have, based on those data, first of all we can do the feature engineering, and then we can find out the important features from our data. Because sometimes, let's say we have 10 columns, so there is some chances only 4 to 5 columns are important for our projects, okay. So we can extract and we can find the important features from our data, okay. So the next step that we have, feature extraction and the feature engineering. Next that we have feature scaling. After that we can do the data preprocessing and all, and then modeling. After modeling, we can apply here the machine learning algorithm. As you can see here, machine learning algorithm based on the data. Let's say we have a regression problem, so we can apply the regression algorithm. Let's say we have like a clustering or classification problem, so we can apply the clustering or a classification based on the problem statement. We can apply the machine learning algorithm. Now after that, what we can do? We can do the evaluation. Let's say in a training phase that we are getting the 80% of the accuracy or 90% of the accuracy, but during the testing phase we are getting the less accuracy. So what we can do in this case? In this case we can do the retraining approach. As you can see here, after that I have written the retraining approach. Model performance, you can do the again all those steps, do the retraining, and then again apply the machine learning algorithm, get the best performance in training and testing as well, and then you can do the deployment and monitoring. Monitoring purpose, you can use any DVC or ML flow, any library, okay. But from this week, first week, we are going to cover till here, till modeling part, machine learning part, and evaluation, monitoring we will cover in our NLP projects third week, okay. So first get the data. After getting the data, as you can see, I have written here. Let me zoom it a little bit so that you can see. So first we are getting the data from our client. We are getting the data. After that, what we can do? We can understand the problem statement. What is our problem statement? Because based on the problem statement we can do the analysis, so that we can get the some of the insights from our data, and based on the insights then we can apply the feature engineering and modeling purpose, okay. Now after understanding the problem statement, we can import all those library, whatever the necessary library that we have. But before this one, from where that we are getting the data? We will get the data from local system like CSV or Excel format, database, any cloud platform, or a third party API. It depends on your clients. So these are the format that we have to get the data. After that we can import the library, then we can do the data cleaning. So as you can see here, I have written the data cleaning step, handling a missing data. So we have a different method to handle missing data. First, delete the missing value, but this is not a correct approach. Whenever we are dropping a data, we have lost our data, some of the data, okay. So this is not a correct approach. Second method that we have, missing impute data with mean, mode, median, depends on the data. You can leave, let's say if you have a categorical data, so what we can do here, we can use the mode function. If you have a numerical features, but it depends on the data and it depends on the column, we can apply a different like a function here, like impute a missing data. Next that we have assign a unique value. So whatever the like a missing data that we have, another method that we have to apply a unique value, okay. Next that we have predict the missing value. So again, this is the another approach that we have to predict the missing value using the algorithm which is support vector machine. So this is the another method that we have to fill the missing value. So these are the method that we have here. As you can see, I have written the missing at random state, missing the completely as random, MCAR. These are the function that we have. These are the method that we have to apply whenever we have a missing data, okay. But it totally depends on your data set. We cannot say, okay, no, in every problem statement you can apply a like a predicting the missing value you can apply, or you can apply the like a mid, mode, median. No, it depends on your data. Okay, so always remember, whenever we are handling a data, these are the method that we have, and it depends on the data set. We can apply a different method. Now as you can see, data cleaning steps. So what we are doing in a data cleaning step, first of all, we can remove the data, remove the duplicate data. So sometime, let's say we are collecting a data. Okay, so we are sending a one Google form. Okay, you can fill this form. So what users are doing, they are filling again and again. Let's say if the first time they are doing some of the mistakes, so what in this case they can do, they can fill again those forms. So it means those are the duplicate data that we have. Okay, so what we can do, we can remove the duplicate data. This comes under the data cleaning steps. Again, handling a missing value. So these are the handling missing value method that we have. After that, filter out unwanted outliers and many more based on your data. So if you have some outliers in your data, so you can handle those outliers as well. Outliers means, let's say we have some data like 1, 2, 3, 10, 20, 30, and one data that we have 1000. So 1000 is outliers. Okay, we can assume 1000 is an outlier because whatever the data that we have, it's under the 1 to 30. And one data that we have is a like far greater than 30. So we can say, okay, 1000 is a outliers that we have here. Okay. Again, different method that we have to handle our outliers. As you can see, I have written here standard deviation method, interquartile method, IQR, percentile capping, standard deviation method, and many more method that we have. But again, we can implement and we can use this method depends on the problem statement and depends on the data set. We cannot say no, in every problem statement you can apply the standard deviation method, you can apply a IQR method. No, it depends on the data set and depends on the problem statement we can apply the method. Now again that we are handling a imbalanced data. So what is the handling a imbalanced data? Let's try to understand this one first. Let's say we have a one column like age column that we have, where we have a thousands of rows, and in the thousands of rows, 900 rows that we have for a male and only 100 rows that we have for a female. So this is the imbalanced data that we have. So what we can do in this case, we can apply a different method for oversampling, undersampling, and ensemble sampling. So these are the methods that we have to handle a missing data. Okay, so I hope till here everyone got it right. Please confirm in the chat section, guys, so that we can continue on the implementation part. Yes or no? Okay, fine. So yeah, resources wise, all those resources that you will get here. So let me show you first of all. So these are the whatever the thing that we have discussed. So these are the machine learning pipeline that we have. Okay, so you can just go to here, my GitHub, and here as you can see I have uploaded the machine learning pipeline PDF. Let me put it down in the chat section so that you can download it from here. So you can download this from here, this PDF file, and now let's try to understand the data set. And before the data set, yeah, let me show you the first of all the data set. So this is the data set that we have, a student performance. We are going to work on the student performance analysis project. Students and performance analysis project. This is our first machine learning project. Okay, and this is the problem statement that we have. The data set consists of the marks secured by the student in the various subjects. Let's try to understand the influence of the parents' background, test preparation, etc. of the student performance, and then we can find out whatever the data that we have. Based on the data set, we can find out the student performance. So this is the data that we have. Overall, the problem statement that we have, like whatever the data that we have. So based on the data set, we can find out some of the insights. Okay, the percentage, the final percentage, the student final percentage depends on the test or depends on the like some other things like whatever the column that we have. Okay, so overall problem statement is to find out the student performance. Okay, now as you can see, this is the data set that we have, where that we have the gender column, race column, parental level of education, launch column, test preparation course, math scores, reading scores and writing scores. Based on this column, we can find out the student performance. So what I can do, let me open this data. I have uploaded this data on my GitHub as well. So what you can do, you can just go to GitHub or you can download it in your Lego system and then you can load it. What I am doing, I am just taking this data from the raw, and now let me import the dataset first. So for this one, I am just going to call import pandas as PD. I hope the problem statement is clear to everyone. Everyone please confirm in the chat. Problem statement is clear everyone or not? Please confirm in the chat. Yes or no? So that we can proceed. Is problem statement is clear to everyone? Yes or no? Okay. So now let's continue. Let's try to import the data first. So I have imported the pandas using a PD. Now let's try to run this data. So for this, I'm going to just call this one, this data from here. Yeah. So df equal to pd dot read underscore csv. I'm going to just call the data. Okay, and df dot hit. Let's try to check the first 5 data. So this is the first 5 data that we have. I hope my screen is visible to you all and the data set as well. Okay, if not, then I will off my camera. If yes, yeah, it's visible. It's visible. So this is the data set that we have. As you can see, we have a different column here: gender, race, parental level of education, lunch, test preparation, math score, reading score and writing scores. Now what I can do, let me try to check first of all the shape of the data, how many columns that we have and how many rows that we have. So df dot shape. So total 1000 data that we have and total 8000 rows that we have and 8 column that we have. Okay, now as you can see, the data set information, gender column. Under the gender column that we have 2 features, male and females. Again, in a race column, we have a group A, group B, group C and group D. 4 features that we have. Parental level of education column, we have a bachelor degree. As you can see here, bachelor degree, master degree and 1 more feature that we have, some colleges. It means the local college or third tier college. Okay, so some college. Again, the launch column that we have, standard and free reduced. As you can see, 2 features that we have. Again, the test course preparation, we have completed or none, 2 features that we have. Math score, we have a different math score, depends on the student performance. Same for the reading score and same for the writing scores. Now what we can do, we can perform first of all the missing data. Let's try to check the missing data, but before this one, let me print the columns. So df dot columns. So you can see, whenever we are going to write df dot columns, you will get all the columns name. Let's say here we have 8 columns, but what if you have thousands of columns? Then you can just write df dot columns and then you will get the all columns name. Now next, let's try to print the null value first. So for this one, we can call the isNull function. Df dot isNull dot, let me run this one first. So you can see we are getting the false and true. We are not getting the understanding. Okay, these are the what is false and what is true. So for getting the more insights, we can write dot sum and then we can call. As you can see here, in a gender column, we have a 0 missing value, race 0 missing value. In our all those columns, we have a 0 missing value. Even if you want to print or if you want to showcase this null value in a graphical format, you can use a missingo function. So as you can see here, missingo, you can just first of all install this library, pip install missingo. Okay, let me write this command so that later stage you can use, and even let me put it down in the chat as well so that you can use this function. So you can just write pip install missingo. I already installed, so no need to install it again. What I can do, you can just call this function import missingo as msno. You can write anything, and after that I'm going to define msno dot, what we are going to define here? Here we are going to define a matrix function, matrix, and whatever the dataset name that we have, df. So it will take few seconds. Yeah, so this is the graph that we have. Let me plug my charger, guys. Few minutes. Okay, yeah, now I am back. So okay, so this is the library that we have, Missingo, where you can check your null value in a graphical format. Whenever you will get a sum of the null value, as you can see here that you are getting little bit, as you can see here, zigzag format. So whenever you will get the zigzag format, it means you have some null data in your data set. Okay, so even you can like a print, or you can check it out your missing data in a graphical format as well. Now let me check it out the duplicate data. So for this, what we can do, we can call a duplicate function. So df dot duplicated dot sum. I'm going to call a sum function so that whatever the duplicate data that we have, we will get. So as you can see, we have a total 0 duplicate data in our data set. Now let me check it out the information of our data. See, we are doing the basics thing as I have mentioned here. First of all, we will get the sum of the insights from our data. So we are doing the basics of insights. Okay, then we can start the EDA and data cleaning. So now what I can do, df dot info. Now as you can see here, we are getting here column name first whenever we are printing a df dot info, null data, whatever the null value that we have, count, and dtag. Here we have a one interesting things. As you can see here, gender is a string data that we have. Again, race is a string data that we have. You can match with your this data. This data. Let's say sometime we are getting here a data in the form of string, but sometime whenever we are printing the df.info, we are getting d type as an integer or as a floating point number. We are getting these types of data whenever we have a date time data in our data set. So what you can do in this case, you can change those data into the date time format in a correct format, and then you can proceed next. Okay, now what we can do, now let's try to check the description of your data. So df dot describe and then run. As you can see here in this description, like whatever the numerical data that we have, like a math score, reading score, and writing score, three things that we are getting all the numerical data. But here as you can see, the mean of the numerical data, reading score, and writing score, all are look like a similar 66, very close data that we have, 66.08, 69.16, and 68.06. so whatever the mean data that we have, we are getting the close data, very close data. Okay, in all our math score, reading score, and writing scores. Okay, now the second that we have, as you can see, the standard deviation. Again, the standard deviation is close to 15 and 14. Both the data that we have, standard deviation is close to each other. Right? Now, third observation that we have, see, you can observe these things during the analysis so that your manager or your client asks, you can explain these things. Okay, in a mean these things are happening, in a standard deviation these things are happening. Okay, these are the null value that we have, so that we have performed these functions. Okay, so you can do the observation and then you can write it down the comment as well. Okay, now what we can do, let's try to explore our data more. Now let's start with the unique. Okay, so df, I'm going to check the gender. Okay, how many unique data that we have? We know in a gender that we have mainly male and female, but let's check unique As you can see, we have a two unique data, male and female. Now next data, let me print this first of all the df, so that I just copy and paste the data. Okay, now I want to check, let me copy and paste, and on this data, okay, how many unique data that we have in this particular column. Okay, so again we can apply the unique function, and as you can see, in a unique column, whenever we are checking the df dot head, we have a, b and c, but in the actual data we have a different things, a, b, c, d and e, 5 unique data that we have, right? So you can check it out each and everything, you can explore your data a little bit, so that you will get the more insights from your data. Now let me check it out, the parent level of education, because as I told you we have a 3 things, but let me check it out here. Let me check it out here. So unique, we have, as you can see, the bachelor degree, some colleges, master. I told you 3 things only, but in our data set, in our actual data set, we have a total 6 unique value. Why I told you in a starting we have a 3 things, so that you can observe. Okay, next time you can now do this type of mistake whenever you can explain someone. Okay, that's why in a starting I told you, no, in our data set we have only 3 unique features, like bachelor degree, some colleges and masters. Okay, but in an actual data set we have a bachelor, some colleges, masters, associate degree, high schools and some high schools as well. Okay, now what I can do, let's check it out here. This is the last categorical data that we have, so let me check it out here as well. I'm just going to copy and paste the column name because of the spelling mistakes. So now let's check. So as for the discussion, we have only 2 unique features, none and completed. Okay, now what we can do here, in our one data we have a categorical data and numerical data. So what we can do here, let's try to create one features for the numerical data and one features for the categorical data. Okay, so for what I can do, numerical features, I'm going to use a list comprehension here. So features for feature in where df is our data set name, df dot column if, what if the df of d type, if the df of feature equal to no, not equal to, let's try to check the d type. So df of features dot d type now equal to 0, and let me put it down this 0 in a string format. Okay, so here let me run this one. Look like I will get some issue. Yeah, column name column, okay, df not equal to, okay, again I am getting the issue, data frame df dot columns. Okay, now I will explain you, don't worry. Let me check it out the length of this function first. Okay, fine. So what I am doing here, as you can see here, I am using the list comprehension. Total data that we have, okay, no, we are getting all data, right? Here the 8 column that we have. Okay, d type is equal to this one. So what I can do now, okay, so this one we can write, yeah, so we can create a numerical features for the numerical data, and for the categorical data we can create a categorical features. So I am using the list comprehension here, features for feature in df dot columns. I'm just fetching the data from our columns. If the features of d type if not equal to what, as you can see here I have defined somewhere object, object, it means a string. Let me run this one. Now we are getting the 3. Why? Because Here you can see we have a 3 numerical data, math score, writing scores and reading score. Let me copy this data again here. And now this time I am going to put it down here, categorical features, and here equal to a string, and then I am going to check the length. Now we have a 5 categorical features. As we all know, here as you can see, the gender 1, race 2, parental level education 3, lunch 4 and test preparation course 5 categorical features that we have. Okay, so we have segregated our data in the form of numerical and in the form of categorical. So I hope till here we all are clear, right guys? Let me know in the comment section. Dataset cannot able to download it. What you can do, let me send you for full. You can just clone this repo. You can just go to here and then you can just click it out here on download zip. So let me send you this link again so that you can download. You can just click on here code and then click on zip. Okay, after that you are able to download. Okay. Now let's proceed next. So I hope till here we all are clear, right? Let me know in the comment section guys if anyone have any doubt. Yes or no, just write it down in the chat section. Yes, no, got it. Okay, that's great. Okay, fine. So now let's proceed next. So what I can do, we have a numerical features and we have a categorical features. Now we have a 3 categorical numerical features, math score, reading scores and writing scores. Now what I want total scores of all those students, whatever the student that we have, I want a total scores of every student. So what I can do in this case, we can create a one column. So df dot total score. Now what I can do, I'm going to add all columns. So df, whatever the column name that we have, first math score, I'm just going to copy and paste each and everything, df plus and then I can change the column name only, reading scores and writing scores. Okay, so what I am going to do, whatever the numerical column that we have, math score, reading scores and writing scores, from this column I want a total scores as well as I want a average scores. So this is the total score that I have written. Now let me write it down for the average score as well. So df average score, and what is the formula of average scores? Total scores divided by 3. Now let me print df dot hit. Now as you can see here, we are getting the total scores of all student, and average scores of all student. You can count 72, 72 and 74. You will get the 218, and these are the average scores that we have for every student. You can check it out even tail part as well, df dot tail, and as you can see we are getting all like a total scores and average scores for all the students. See why I am creating this total scores and average scores, because at the end, as for the program statement, what we are going to check the performance of the student. So performance depends on the scores and the average scores, right? So that's why I'm just checking the average scores. Now next what I can do, as you can see the people have average scores. So again we can create one column based on what? Based on this percentage we can set some of the criteria. Okay, if the people have above 95 marks, they will get outstanding. If the people have 80 plus marks, they will get like A plus, B or C, like this one. Okay, so now let's try to create one more column. So for this one what I can do, first of all we can define the pass marks of the student. So pass marks we can define Let's say in a usual day, like in our college and schools, we have a pass marks as a 30 and 35. So let me define 35. 35 is a pass marks because we have set the criteria. Okay, if you have a above marks, above on 35, then you passed, else you will get failed. Okay, so this is the criteria that we have set. Now DF, and what I can do, the percentage, I have written somewhere the percentage, right? No. So what I can do, let's create a percentage column. So percentage, based on what we can create a percentage. So DF based on the math score first of all, plus, again let me copy the same thing now. Why I'm just writing the same thing again and again. Divided by 3. I hope we all understand why I have written divided by 3, because we want to check the percentage. Okay, no, it's not here, it is here. First of all, we can calculate all those marks, whatever the marks that we have, math score, reading scores and writing scores, and based on this we can calculate the percentage. Let me run this one. It's working fine. Now we can write a function. So def of, we can create a function grade. We can define this percentage, and then we can write a condition. Okay, if the percentage is greater than or equal to 95, then we can say okay, these students will get outstanding marks. Now the next condition again we can write. So what I can do, let me copy and paste same thing again and again. No need to write again and again same thing. Let me just copy and paste. We can do the little bit changes. Okay, now percentage above 95, they will get the outstanding. If the people have above 81, they will get the A marks, A. If the people have 71 above, they will get B. You can write it down based on your assumption. I am just writing based on my assumption. Now above 61, they will get C. Above 51, they will get D. Above 41, they will get E, or else return fail. So this is the condition that we have. Okay, I've just written the simple. First of all, I'm just calculating the percentage. After that I've written the condition. Okay, if the people have above 95, they will get outstanding. Above 81, they will get A. Above 71, B, and so on. Else, if the people have less than 41, they will get fail marks. Now I am going to define the grade. So df grade, df dot apply, I am going to call a apply function. Apply, I am going to use a lambda function here. Lambda dot x grade. What a grade that I am going to define? grade. Grade x of what? X of this percentage. X of percentage, and then where I am trying to add here in a column. So for this axis equal to 1. Now let me run. Okay, else block that I am getting the issue. Okay, indentation issue that I have, nothing else. Okay, again under the grade section. Okay, little bit mistakes. So lambda not here, x is here. LAMB DA. Now again the issue apply. Okay, everywhere I have a spelling mistake. Now it's working. Now let me check that head part again. Okay, so this is okay, none that we are getting. Why none that we are getting here? DF that score that I have written here 35. So okay, I hope this one is fine. Let me debug why that we are getting none function. Let me run this one again. Okay, again none that I'm getting. So df score marks. Okay, so the same thing that I have. Find the percentage wise. Okay, so here is the little bit. Okay, fine. Now let me run. None that I'm getting. Grade. Look like this is the spelling mistake. No, where I'm doing the mistakes. So grad, grade, created, column, fine, return false. Okay, okay, got it. Anyone tell me the mistakes where I'm doing the mistake? Anyone? Where I'm doing the mistakes? Yes, no? I'm just defining here. As you can see here, I'm just defining. Okay, you will get the outstanding A, B and C. But what about the return? Because I want to store somewhere now. So we can call a return function here. Okay. Now we will get the output. Little bit mistake. Now you can check it out. Now as you can see, we are getting the grade here. I hope got it right. Why we are getting the issue? Okay, so we have created the one more features, right? We have created one more features, grade. So based on the grade, based on their scores, we can say okay, these are the peoples. Based on their score, they will get the A grade, B grade, C grade and D grade. As you can see, I have written the condition. If the people have 81 plus marks, then they will get the A marks, A grade. As you can see, if the people have greater than 71, then they will get the B. So it means our conditions are working fine, right? now again what I am doing here, as you can see right now that we have here categorical feature is 3 and numerical feature is 3 and the categorical feature is 5. Now let me copy this again and then we can rerun. Length of numerical features. Now you will get 6 features. Why? Because as you can see 1, 2, 3, 4, 5, 6. If you are going to rerun your this categorical features again, you will get see 6, because as you can see here 1, 2, 3, 4, 5 and the last one is 6. Okay. So even in this way you can check it out. Now what we can do, let's try to check how many students get the full marks. This is the question, because from the data you need to find out the insights, right? So in the insight you can create a sum of the question. Okay, these are the data that we have, but I want to check it out. Okay, how many students will get the full marks? So for this one again we can write out the condition. As you can see here we have a 3 column, math score, reading scores and writing score. We can find it out in every column. Okay, in a math score how many people's, reading scores and the writing scores. Okay, so let's create a one by one. For the math score, for reading score first equal to what I am going to define. First of all I am going to take a reading column, reading score column, this one only, df, and then here we can define our data, reading score equal to what I am going to call equal to, because I want to check okay how many, because in an exam we have 100 marks, like every paper we have 100 marks, and based on the 100 marks we are getting the marks, right? So we want to check okay how many people they have got the 100 marks or full marks. So 100, here we can call the average function. So average dot count, I want to check the average count. Now let me look like we will get some issue. Yeah, average spelling mistakes, right? df dot reading scores that we have collected here. Fine, let me run this one again. Okay, now again same issue. Average dot count that I have defined here. Okay, equal to 100, fine. Okay, now let me do one thing. Count average somewhere I thought I have defined, no? Average score somewhere that I have defined. Okay, so this is the average score that I have defined because of this column, average score. Now let me know. Now as you can see, total 17 students, they got the full marks in a reading score. Total 17 students. Now what I can do next? Let me check it out on math score column. So I'm going to just change this one, math score, and this one is a math score. Total 7 students got the full marks. Now what we can do, you can check it out in a this one, writing score. Okay, so same thing, nothing else. You can just copy and paste this one, copy the column name, or you can just write it down the column name, math score, where the writing score we can write here, writing score, and again a writing score. Now total 14 students got the full marks in a writing scores exam. Okay, so this is the average or like a total count that we have. Now what we can do, as you can see from these insights, can anyone tell me the insights of this data? Can anyone tell me the insights of this data? Insights of these three columns, 48, 49 and 50. Yes, anyone can tell me the insights of these three columns only, nothing else. Three columns insights. I want to know the insights of these three columns. Just try to participate, guys, because it's understanding about your data. If you understand your data, then you can say, okay, these are the insights that we have from this column. Else no. Let's say tomorrow that you will get the data from your client, and next day, again in the next day, if your clients come and then they will ask you some of the question from your analysis, then how you can explain? Okay, so just try to focus and try to understand this one. As you can see here, from this data, from these three columns, we are getting the good results in the reading scores, writing scores, but as you can see, the worst results that the people are getting in the math scores. Yeah, even my math score is not too good and too bad, but yeah, I'm the average student in math. But as you can see, for the our analysis here in the math scores, the worst result that we are getting here, only the 7 students, they got the full marks, right? So you can say, okay, these are the analysis that we have. Okay, and the best performance result that we have under the reading score, because everyone know how to read, right? But yeah, some of the people they are big in the math, but yeah, it's fine. This is the analysis only, nothing else. Now the main part that we are going to start. As you can see here that I have written here in our analysis, in our pipeline, machine learning pipeline, first we will get some of the insights from the data, and based on the insights, then we can start the EDA, exploratory data analysis. Now the time that we have to start a exploratory data analysis. Okay, exploratory data analysis. Let me take some water, guys. Just few minutes. Let me take some water. Okay, now the time that we have to start our exploratory data analysis. Till here we all are clear, right? Anyone, any doubt? Yes, no? Let me take some new column so that it will be visible to you. Now the time that we have to start exploratory data analysis. So in exploratory data analysis, first of all we will visualize a score distribution, a score part, whatever the score that we have in our data. As you can see here, a score part that we can visualize first. So what I'm doing here, let's try to first of all define our data, import the SNS, SEA view as SNS. I'm just going to import the SNS. Okay, yeah, import the SNS. After that we can call SNS dot histplot. Then we can define our data. So data equal to, what is our data name? Data frame name df. X I'm going to call average score. Average score, and yeah, average score is fine. Beans, let me define some beans as well. I will tell you what is beans, so no worry. Beans, and I'm going to define a KD plot. So KD equal to true. Yeah, it's fine. KD equal to true. Now plot plt dot show. See, even you can visualize more function at a time, more column, like more than one column at a time. Okay, beans, I have to do a column here, comma. Now plt, because I'm using the matplotlib, so I need to define here import matplotlib as plt. Okay, matplot. Okay, model matplot. Okay, no issue. You can just check it out, this one. So as you can see, even what I can do, let me define the mode graph. As you can see right now I have a one graph. So even you can define the more than one graph as well. So for this, what we can do, we can create a subplot. We can create a subplot. So first subplot we can create for this one, plt dot subplot. And here you can define, as you can see, where the data that we have 121, and before this one you can define the figure size and axis, comma, axis equal to plt dot, for that we are going to define, the subplot dot one row and two column, like one row, one graph that you want, like two graph that you want in one row. One is here and the second one is here. So we can define one row and in a column two graph. And the figure size, if you want figure size, you can define figure size equal to something like 12 or 8 is fine. First subplot that we have written for this one. Now the second subplot that we can write for the our next graph. Now the next graph, what I am doing, let me copy the same thing. I am going to change here till here is fine. I am going to define the hue function only. I will show you the difference, don't worry. So the hue equal to, what is our column name here that we have, the gender. Okay, subplot somewhere that I have written, this one, no, subplots that I have written S. Okay, subplot has no attribute, then this one to fill 8 axis that I have written. One issue that we are getting. Anyone tell me what is the issue that we have here? Anyone? Let me import the like matplotlib that we have imported, but let me check it out. Now let me check it out here. Okay. Matplotlib.pyplot subplots that I have written is fine. Module matplotlib subplots. Anyone tell me their mistakes? Look like everything is fine, but why I don't. Okay. Subplot is fine, right? Purple double P where? Okay, got it here. No, again subplots here. No. Okay, I am also thinking like a spelling mistake that I have. Subplot. No, here, not here. Here. Okay, so subplot here that we are getting. Okay, yeah, here in a hist plot that I have written. Now it's fine. Sorry. Now let me run. No, again the same issue. Why? It's occurring the same issue again. Figure dot subplot is totally fine. The 7 that I have defined, no issue in this case. Color that I have defined, the like 1 2. Let me do googling, guys, because let me explore a little bit. Or what I can do, let me rerun this cell, all cell. Restart and rerun. Purple line number 1 plot plt dot subplot. Yeah, plt dot subplot that I have written here. Jinkyo, you have written the subplots. No, it's a plots. S function that we have. Pyplot. Let me debug some googling as well. This function is fine. Or let me, what I can do, let me debug it, guys. No, again the subplots where 2 is given, 1 and 2, 121 and 122 that I have written here is fine. Yeah, it's going well. Average of X data and Y data. Yeah, I'm just executing all functions one by one. Yes, look like somewhere. No S. Okay, I'm just checking with no S. No, it's a subplot S. We can define S here, powerful. Even the functions matplotlib no attribute, even the starting point is fine. What I need to do here, Yeah, now it's fine. Now I am audible. I will tell you the mistakes. Yeah, first of all, libraries are not installed. Okay, actually I installed Matplotlib in a different environment and I am executing in a different, no audible, no audio. Now can you please confirm? Audible? Yes, no? Yes, okay. So actually I have created an environment in another environment and I am executing this code in another new environment. Okay, and the Matplotlib installed in my old environment, so that's why I got the issue. And yes, as you can see here, yes, subplots, whenever we can define a function, we can use a subplots here. So here I'm just executing the first thing. First thing, it means row. First it means how many rows that you want, and second it means in a column how many columns that you want. So as you can see, one row that I have and the images that we have 2. Second, figure size, we all know what is the figure size, so I am just x and y that I have defined here, nothing else. Next, what I have done here, subplots 1 to 1. Why 1 to 1? So the 1 and 2, one row, second column, and first graph that I want. Here the second graph that I want, so that's why I defined 2. And this is the like a hist plot that we have, where we have defined the function, average, wins, KD plot. Like this is the KD function graph that we have. Let me remove this one, KD. Now you can see the graph. Now you can see your graph, and whenever we can define the KD, now you can see the graph. Okay, so these are the normal distribution graph that you will get whenever you can define this function here. Okay, got it till here, everyone? Little bit environment in issue. Okay, fine, great. So now let's proceed next. So can anyone tell me the insights from this data, this graph? What insights that we will get from here? Insights from this graph. So insights of this graph is, as you can see, the male student here, as you can see the male and female that I have defined the hue. Male student performed well as compared to female student in a exams, whatever the exams they gave. As you can see, the math score, reading scores and the writing scores, male student performed well as compared to the female student. Okay, now what I can do, let me copy this same code first, 2 line of code. What I am going to do, right now we have implemented based on the average. Okay, so next thing, we can take a gender, average, gender, as well as one more column that we have here, launch. This column we will take 3 column. Okay, so now this time I want a 3 graph. So I'm going to define 1 to 3. Here I'm going to start 1, 3. Just try to understand this one, guys, because whenever you are going to define, you can understand this one. Okay, how we are defining x and y. Okay, the subplot that we are going to define 1 for 1, next function. Okay, now plt dot, which function that I want the same function, hist plot, plt dot hist plot, and now data equal to df. This is the function name that we have. Now what data that we have, x equal to average function, average, whatever the average that we have created here somewhere, yeah, average here. Okay, so average, x average that I am going to define. Now next, KD function, let's try to use the same thing, KD function, and after that we can define something else. Let me close this one. Yeah, KD function, and then here I am going to define as a, one second, let me close this one here. Yeah. So KD I want as a one more column that we have, lunch column. Based on the lunch column I want to define. Now the next, this is the first, second I want 1 4 2, and third 1 4 3. 1 4 3. Okay, now here I'm going to just copy and paste the same thing. First this plot, now df x based on what? So here I'm going to define something else. For something else, I want a data in the form of gender. So df, I will tell you why I want this one as a gender. I did not want gender equal to what? So let me check the spelling. Female. Gender equal to female. Let's close this one here to here. Okay, now x, same thing, average I want, KD true and lunch is fine. Now next, just try to focus on the code right now. I will explain you what I'm doing here, and then I'm going to call this one plot show. Okay, so again we got the error, his plot. Where his plot, again the same, look like we got the same issue. Okay, but this time that I have something else. Okay, so the figure size is fine. Subplots, x average female. Yeah. Okay, so this is the graph that we have. What I am doing here, as you can see, the first graph that I am taking the average only, and the hue that I am taking as a standard and free. Again, second for the gender male, this is the 4. Okay, so everywhere that we have average, fine. So second graph that we have taken this graph as a female gender, and third graph that we have taken this one as a male. So what insights that we are getting from here, as you can see, the standard lunch, as you can see, this is the color. Just focus on the color, guys. So standard lunch, whenever our student, they are taking the standard lunch, they are getting the good marks in the exam, they perform well in the exam. And whenever the peoples and the students, they are taking the free, they are getting the less marks. Even in the female, as you can see, female here in this column, females, whenever they are taking the standard marks, they are getting the standard food, they are getting the good marks, and for the free food they are getting the less marks. Okay, so standard lunch helps the perform well in an exam based on the male and female. As you can see, in a female standard, whenever the people have a standard male, they are getting the good marks. Got it, everyone? Yes, no? Please confirm in the chat. Yeah, definitely. If you have a good food, if you are taking a good food, then definitely you can focus on your exam. Definitely you can focus on your a learning. Okay, if you have a bad food, like something else you can think. So definitely it will impact on your exams. Okay? Up till here we all are clear, right? Yes, no, please confirm. Okay, now what I am going, so we have covered the gender column, lunch column, and the average column. Now this time we have to implement the parental level of education. So definitely this column will impact good, guys, because depends on our parents. Let's say if our parents is more educated, then definitely we can focus on more on our education. Okay, so what I'm doing, I'm just copy and pasting the same code. Now I want the 3 column, average, and now this time I want based on what? Based on this partial level of education, parental level of education, sorry. Based on this parental level of education, male and female, the same thing that I have defined. KD prod is fine, I'm just changing this one. And after that you can just check this graph. Now you can check this graph. Let me change this one. 25. Yes. So this is the graph that we have. See this graph. In this graph, as you can see, this is some of the colleges. Our parents, it means whatever the student data that we have, their parents is passed from the some of the colleges, it means the local colleges. You can think some of the local college, again same for the male and again for the female. Okay, because this graph, this color you can find out here. So this graph is we are getting the good, and as you can see the less graph that we are getting from where master. Okay, our parents had like less parents have completed the master degree, and the more parents have completed the bachelor degree from some of the local colleges. So this is the insights that we have from our this data. Apart from this, in a general parents, as you can see in a general parents education, like some colleges, they don't help their child so that they don't perform well in the exam. So based on our parents, sometimes we perform well if our parents is well educated. Okay, so this is the analysis that we have. Okay everyone, now task time. So what you can do, you can implement on this column based on this race entity column. You can implement. Okay, based on this. Okay, if the students from the group B, then you can say, okay, if the people from group A or group B, they perform well in the exam. If the people from group C and D, they didn't perform well in the exam. Okay, so you can do the analysis on this one based on the race entity column. So this is your task. Now I will show you one of the very interesting graph. Let me print first of all. So actually I have this code. I'm not going to write this code, so I'm just copy and pasting this code same. So this is the code that I have. As you can see, what I'm doing here, I'm just defining the size, gender. Based on the gender, I'm just counting the value counts. Color, black, red and blue. Labels, male and female. After that, circle that I have defined. Okay, I want these types of circle. You can define the another circle as well. Okay, even if you want to define the pie chart, you can define the pie chart as well. Okay, so then I am defining the figure size. Pie chart I am going to print. So pie chart, size that I have defined here. Color, okay, I want this color. Label, based on this label, male and female. Shadow, and this is the title that I have written. As you can see, this is the graph. It means in our data, 51.80% the female member that we have and 48.20% male member that we have. Okay, now again what you can do, if you want to check it out on some other column, you can just copy and paste the same data, and then you can change the column name. So I'm just changing the column name based on this column, whatever the column that I told you for the like a test. Okay, task purpose. So I'm just going to change this one, and color wise, first let me define the label. So label that I have group C, group A, group B. So these are the label that I have. Let me copy and paste from here. This is the data that we have, right? Okay, so from here I have this one. I'm just changing the color. Now let me run. As you can see, so group D, as you can see in this graph, group C are the greatest in this data. Our data, we have a group C is the greatest member that we have in our data. Got it, everyone? Please confirm in the chat. Analysis, we are doing the visualization and we are understanding, okay, like whatever the less data that we have, whatever, like which column is impact on the performance of our student or not. Okay, so we are checking these things only, nothing else. Let me know in the comment section if anyone have any doubt. Even if you want to print a pie chart, you can just call plt.pie and whatever the column that you want to print. So let's say this time I want to print on some other column, test preparation column. Test preparation column. So I'm going to just define the ds.test preparation column dot value count, open close bracket. After that you can define the color. So I need some color like colors yellow, and I need a red or something else, whatever you want. Labels wise what I want, So label, how many label that we have in our data? None and completed. Two things that we have, right? So I'm just going to define two things, labels and this one, two data. Now apart from this, what you can define? You can just define your size part. No need to define a size, it's totally fine. Let's define the title if you want. So title, test preparation, and then we can plot plt dot axis, and then okay, plt dot show something. I thought, yeah, this is the graph that we are getting, but what I'm going to define first, let me auto pct something. Okay, let's define the auto pct as well, so that we will get some little bit better insights. So here I'm going to define, and the column by is totally fine, so I'm just going to define the axis function here. Now let's run. Okay, so the same issue that I'm getting here, let me check it out, the error. Okay, so the first graph is fine, the second graph that we are getting, let me add the plt dot title launch something, and the font size I'm going to define what, something 20. Okay, the same issue look like, okay, none completed auto pct labels. Okay, sorry. Now let me check it out. Okay, so this is the graph that we have. No, launch is not, it's a test. So this is the graph that we have. As you can see, the number of students who have extended lunch are greater, and the completed is second is a completed. So how many students they have left this exam? 64% of the student, and only 35% of the students they have completed the test only. Got it everyone till here? Yes, no? Little bit boring, right? Okay, so what do you want? I can just let me do one thing from the next class. I can just write it down each and everything before the class, and then I will explain you in the class. It's fine to everyone or not? Or shall we do the live coding? Okay, so yeah, what I can do, let me write it down all the codes before the class, and then I will explain you in the class each and everything. But let me finish the today class first, because I need some more analysis as well. Okay, so let me complete till the EDA part. So one more thing that I want to plot here, I have a code, let me copy and paste the same thing here. So what I have done here, I have plotted a count plot here. Parental level of education, where I have a blue, title, comparison of that I have defined, and this is the graph that we have. So from this graph, what the analysis that we are getting, largest number of parents are graduated from where? Graduated from some of the colleges, some of the local colleges. Okay? Everyone? Yes, no? Okay, fine. Now what I can do, let me copy and paste the same code, whatever the code that I have here. I didn't need the first code, but let me find even the second code. I just need the X level. So X level, I just want the lunch column instead of this one. And then I will show you the comparison of lunch. Yeah, so as you can see in this column, don't focus on this one guys, X level and Y level, just focus on here. As you can see in this graph, standard, our students are taking the standard food more as compared to free food. Okay, now the another task here is the lunch time is intake has any impact on the student performance. You can just check it out based on the graph. Is the lunch time intake has any type of impact on the student performance? Definitely it's impact. Now this is your turn, you can find out. Okay, now this is your turn, you can find out the way. If the people are taking their standard food, is there any impact on the food? If the people are taking a free food, is there any impact on the performance in education? Okay, so this is your turn, you can find out. Okay, now this is for the analysis. This is for the analysis. Now the time that we have to check the outliers. Check the outliers. So first of all, we can plot the pair plot, SNS dot pair plot, and df data I'm going to define and hue as a gender, and then plt dot show. Let's try to get some of the insights from our data, like from our pair plot as well. So this is the pair plot that we have. From this pair plot, it is clear that all the sources increase linearly with each other. As you can see, it's increased linearly. Every graph, all the graphs are increased linearly. But as you can see, somewhere that we have some outliers as well. It's increased female, male. But most of the time, as you can see, female members are the outliers. Don't worry, we will get some more insights as well. So this is for the pair plot. You can say, if someone asks you, okay, just tell me some of the insights from this data. So what you can say? Okay, in this graph, scores, whatever the scores the people are getting, they are getting the increased scores, increasing in every exam. In a math exam, 70, reading exam, 75, writing exam, 85, like this one, it's increased linearly. Okay, now the time that we have to print a box plot something. So SNS dot box plot, whatever the data that you want to define. So df dot I want to check on math score. Under the string you can define math score and color equal to something like, let me define red. Now plt dot show. Okay, so red, math score is fine. Color, okay, let me define some other color, is sky blue. Why? COLOR, color, fine. Now what? Invalidates index. Okay, here is the issue that we have. No. Okay, so this is the graph. Okay, again the issue is sky blue, BLEW. I'm doing lots of spelling mistakes, right? This is the graph that we have. As you can see, can anyone tell me the outliers or the analysis of these outliers? I just want to understand the analysis of these outliers. Nothing else. Analysis of this function or this graph. Here as you can see, people are getting, you can compare as a 35 to 100 marks. But some of the people, they are getting the less marks. As you can see, some of the people are getting the 0 marks as well. It means the people are not attending the exams. That's why they are getting the 0 marks. Some of the people are getting 10 marks as well, 15 marks as well. Okay, so this is the insights that we have from this graph. Now we have checked out the math score. Now let's try to check it out on the average score. So what I can do, let me copy and paste, and here I'm going to write average. Okay, again the spelling mistake. Yeah, so again same graph that we have. little bit, as you can see, 1 2 3 4 5 outliers that we have from here. Anyhow we can handle it. If you want to plot a multiple subplot or sub box plot like this one, what you can do, you can just define the box plot like this one. Whatever the box plot that we have defined here now, you can define a box plot like this one. Okay, so what I can do, and let me copy and paste the same code. I have done first 4 graph that I want in a one row, 4 graph, 141, 42, 43, 44. Then math score, reading score, and writing score and average that I want. I want to check on the outliers on our data. So as you can see, this is the somewhere outliers that we have after 40, everywhere after 40, somewhere in a math score that we have after 25, but everywhere that you can find after 40. So these are the like outliers that we have. Now let's try to check it out the correlation between the two graphs. So for this, what I can write, df.cord. So here math scores 100, reading scores the people are getting here everywhere 100 you can find, but the correlation you can find little bit here, like in a reading scores, writing scores and the total scores. What I can do, let me define all column first somewhere. So I'm just defining the numerical data, num data equal to add underscore, and whatever the column name that we have, these 3 column name that we have, writing scores, reading scores and math scores. I'm just defining this one, and then I'm going to call 3 functions from our data, from our this df data, sns.pairplot df.ilog. I'm just taking all rows, 4th column, 1st, 2nd, 3rd, 4th column, last from 4th, 1 2 3 and 4th, only these column that I want, 4th to last. This is the pair plot that we have. Again the same analysis, we can say okay, all the pair plots have the similar or seems like a similar linear relationship with the other variable, right? As you can see, linear relationship that we have in a all column, right everyone? Even as you can see right now we have plot here the heat. You can check it out with the visualization, as well. So what I can do, let me plot the visualization for this one as well. Okay, so I'm just going to call df.cord, where I'm going to define, no, not here, sns dot or df.cord you can define, and here I'm going to call sns dot heat map, open close bracket. Here in not I'm going to define something like true, and the cmap color, what I want, color I want to check color on heat map. See, you can just do the googling and then you can check it out whenever you face any types of, because right now I have not remember the cmap. Okay, got it. Let me define this one, and then what I can do, plt dot show. If we will get the issue, resolve it, simple. Yeah, we got the issue. cmap object has, okay, object has no properties. So what I can do, let me define this one as well. Yeah, here as you can see the data, first the total score. Where is the total score? This one. Total score is highly correlated with the individual score. Here you can see the math score, highly correlated data, reading score, highly correlated data, writing scores, highly correlated data that we have in a total scores. You can do the observation, guys. Okay, you can check it out the data and then you can do the observation. Again, in a reading score is also highly correlated. Where is the reading score? This is the reading score that we have. So reading score is highly correlated with what? With the writing scores. So you can just compare reading score here and the writing score here. reading score and writing scores, 95% correlated data that we have. Okay, same reading score here and the writing score here, 95% highly correlated data that we have. Math score, let me check it out. The math score doesn't have much highly correlated, so it is not necessary if we if the student perform well in the math scores, do perform well in the other like a reading scores and the writing score as well. No, because the highly correlated data that we have only the writing scores versus the total scores, reading scores versus the writing scores, 95%. Here as you can see the 97% correlated data that we have. Okay, got it everyone? Yes, no? Yes, no? Write it down in the chat please. Yes, no guys? Okay, got it. Now, next what we can do, we can check the transformation, normal distribution. Normal distribution. Or what I can do, let's do pending this part from tomorrow. Or shall we print today? No, let's wait this part till tomorrow. We can discuss this part tomorrow. Normal distribution. Let me write it down which topics are left for today, so that we can continue tomorrow from here without any expectation. Okay, so tomorrow important topic, normal distribution. These are the important topic that we have for tomorrow guys, so make sure you can join the tomorrow class. Normal distribution important topic, hypothesis testing, chi-square test, Pearson test, k-square normally test, experiment test. So these are the tests that we can perform tomorrow. Okay, yeah guys, let me know till here if anyone have any doubt, any query in the comment section. And don't worry, everything you will get on the GitHub repo. Okay, and one more thing, tomorrow we will create one group so that whatever the important thing that I have, I need to share in the group. Okay, so yeah guys, so that's all about the today's session. Let's see you in the tomorrow class. Okay, yeah, bye everyone, bye.